Welcome. Let your shoulders soften and let your breath slow, just a little more with every word. There is nowhere to be right now, nothing to solve, nothing to hold on to. Tonight we drift through a quiet question that scientists and philosophers have wondered about for a long time. Could the universe itself, in some deep way, be alive? We begin gently with what life truly is. Biologists describe life through 7 quiet characteristics: order, energy use, growth, adaptation, response, reproduction, and regulation, all woven together in every living thing. All known living organisms are made of cells. From the smallest bacterium to the tallest sequoia, life on Earth is built from these tiny, self-contained chambers. Each cell holds fluid, structure, and instructions within a delicate membrane, working quietly to keep itself alive. Trillions of them cooperate inside a single body, like countless small rooms glowing with the same soft light. It is a humble beginning, and yet from it, everything living has grown. Cells maintain homeostasis to regulate internal conditions. Inside every cell, tiny mechanisms hold temperature, moisture, and chemistry in careful balance, even as the world outside shifts and changes. This steady inner calm allows delicate processes to continue undisturbed. It is much like a quiet room kept at just the right warmth, no matter the weather beyond the walls. This balance, held moment by moment, is one of life's oldest and gentlest achievements. Metabolism converts energy from the environment into usable forms. Every living thing borrows energy from its surroundings, sunlight, food, or warmth, and quietly transforms it into something it can use to move, grow, and heal. This slow exchange happens constantly. Without noise or effort, we notice. Even as you rest tonight, this quiet conversion continues inside you, sustaining your breath and your heartbeat. Life, in this sense, is a gentle, ongoing exchange with the world around it. Living organisms grow by increasing biomass through cell division. A single cell becomes 2, then 4, then many more, each one a faithful copy holding the same quiet instructions. This is how a seed becomes a tree, and how a single fertilized cell becomes a sleeping child. The process is patient and unhurried, unfolding across days, seasons, even lifetimes. There is something soothing in knowing that growth, at its heart, is simply gentle repetition. Reproduction allows organisms to pass genetic information to offspring. In this quiet act, life reaches beyond itself, offering its instructions to a new generation. A parent's careful blueprint, refined across countless years, continues onward through their young. It is one of life's oldest promises, that something of you continues, folded gently into another. The light entering your eyes tonight left stars that existed long before this promise ever began on Earth. Neon stores hereditary information in a double helix structure. Inside nearly every cell lies a long, gently twisted ladder, holding the instructions for building and maintaining life. Its 2 strands wind around each other in quiet symmetry, like a slow spiral staircase reaching into darkness. Along this ladder, tiny chemical letters spell out patterns passed down through countless generations. It is a small, coiled library, holding within it the memory of everything that came before. Evolution by natural selection shapes populations over generations. Small differences between individuals, passed quietly through reproduction, allow some to endure a little more easily than others. Over vast stretches of time, these gentle differences accumulate, reshaping species slowly, almost imperceptibly. Nothing here is sudden or forceful. It is simply time, working patiently on countless small variations. In this way, every living thing carries a quiet inheritance shaped by ages past. Organisms respond to external stimuli through sensory systems. A plant slowly turns toward the light, a creature stills at a distant sound, a leaf curls gently from unexpected cold. These quiet responses allow life to notice its surroundings and adjust with care. Even the simplest organisms carry some small way of sensing the world around them. It is life's quiet attentiveness, always listening, even in stillness. Adaptation allows species to survive in changing environments. Across long spans of time, life reshapes itself in quiet response to shifting conditions, a thicker coat for colder winters, a deeper root for drier soil. These changes are not chosen, but slowly favored, generation after generation. In this way, life remains gently responsive to the world, bending without breaking. It is a soft kind of resilience, built not from force, but from patience. Let your shoulders soften now, sinking a little deeper into whatever is holding you. There is nowhere to be, nothing to solve, no thought that needs finishing tonight. With each breath out, let your jaw loosen, let your hands grow heavy and still. You can simply rest here, drifting gently, as the next quiet fact rises softly to meet you like a slow tide reaching the shore. Energy flows through ecosystems from producers to consumers. Sunlight settles on a leaf, and something quiet happens. That light becomes food, becomes growth, becomes life stored gently in green tissue. A grazing creature takes in that stored sunlight and in turn becomes nourishment for another. Step by step, the sun's warmth travels onward, passed hand to hand through the living world, never lost, only transformed. Entropy production is a hallmark of living dissipative systems. Every living thing, in staying alive, quietly stirs the world around it, releasing warmth and disorder outward as it works to keep itself organized. A body humming with metabolism is, in a sense, a small storm of order rising within a wider calm. This gentle churning is not a flaw of life, but one of its subtle, necessary rhythms. Living systems maintain order by exporting entropy to surroundings. To stay whole, a body must constantly release what it no longer needs: warmth, waste, spent energy, sending disorder outward so that order can remain within. It is a quiet exchange, breath by breath, one system giving to another so both may continue. In this way, staying alive is less about holding still, and more about steadily, gently letting go. Autopoiesis describes self-maintaining chemical networks in cells. Inside every cell, countless small reactions quietly repair, rebuild, and renew the very structures that make those reactions possible. It is a soft, closed loop of creation, the cell continuously remaking itself from within, using its own materials to preserve its own shape. Nothing outside directs this. It simply happens, again and again, like a hearth that tends its own flame. Image parts, image prompts, a gentle glowing cross-section of a cell interior. Tiny luminous molecular strands weaving and repairing themselves in a soft circular pattern. Warm bioluminescent blues and golds, dreamlike microscopic illustration, calm and orderly. Narration viruses blur the boundary between living and non-living matter. Too simple to grow or feed on their own, they lie dormant like tiny sealed letters, waiting. Only inside another cell do they awaken, borrowing its quiet machinery to make more of themselves. They sit gently on the edge of life's definition, neither fully alive nor entirely without it, a soft, unresolved question drifting at the threshold. Prions are infectious proteins with no genetic material. Unlike almost everything else that spreads through living tissue, a prion carries no code, no instructions, no memory of its own. It simply folds incorrectly, and in its quiet, persistent way, nudges its neighbors to fold the same way too. There is no blueprint here, only shape, spreading slowly like a single ripple gently reshaping the water around it. The origin of life on Earth remains scientifically unresolved. Somewhere in the planet's early restless chemistry, non-living matter began, quietly and gradually, to organize itself into something that could grow and copy itself. Scientists believe warm pools, deep vents, or ancient clay may have offered gentle cradles for this shift. We still do not fully know the exact moment, but the mystery itself feels less like a gap and more like a soft, open horizon. Extremophiles show life can exist in extreme environmental niches. In boiling springs, frozen ice sheets, and crushing ocean depths, tiny organisms quietly thrive where almost nothing else could. They have learned, over long ages, to bend their own chemistry to fit conditions that seem impossibly harsh. Their existence is a soft reminder that life's edges are wider and gentler than we once imagined. All life on Earth shares a common biochemical ancestor. Beneath every leaf, wing, and heartbeat lies the same quiet chemical language, the same kinds of molecules, the same basic code, passed down through billions of years. Somewhere in the deep past, one small ancestral lineage gave rise to everything that followed. It is a gentle, unifying thread connecting every living thing to a single, distant beginning. All life on Earth shares a common biochemical ancestor. Beneath every fern, feather, and whisper of breath lies the same ancient chemistry, the same handful of molecular letters spelling out life's many forms. Scientists trace this thread back to a single humble lineage, adrift in early Earth's waters, long before anything walked, swam, or sang. It is a tender thought that every living thing, however different, remembers the same distant beginning. Consciousness is not a required criterion for biological life. A mushroom needs no thoughts to grow toward moisture, and a bacterium needs no awareness to divide and thrive. Biologists define life through metabolism, reproduction, and response to the world, not through inner experience. Somewhere along evolution's slow path, awareness arose in certain creatures, yet countless living things flourish quietly, fully alive, without ever knowing they exist. Let your shoulders soften now, sinking a little deeper into whatever is holding you. There is nothing here that needs solving, nothing waiting to be understood before you rest. Let your breath slow, each exhale a little longer than the last, like a tide easing gently back from shore. Just let the thinking quiet and let yourself be carried, unhurried, toward sleep. The universe began 13.8 billion years ago in the Big Bang. In an instant beyond imagining, all of space, time, and matter emerged from an impossibly small, impossibly dense point. There was no explosion into empty space, but space itself unfurling everywhere at once. From that first breathless moment, everything we have ever known began quietly taking shape. The universe has been expanding since its earliest moments. Space itself has been stretching, gently carrying galaxies farther apart, like dots drawn on a slowly inflating balloon. This is not matter flying through space, but space itself growing wider with each passing age. Even now, in this quiet moment, the universe continues its slow, patient unfolding. Cosmic expansion is accelerating due to dark energy. Rather than slowing under gravity's pull, the universe's growth has been quietly speeding up for billions of years. Scientists call this unseen influence dark energy, though its true nature remains one of the cosmos's softest mysteries. It fills the space between galaxies, gently pressing them apart, faster with each passing age. Galaxies form vast filaments connected in a cosmic web. Across the largest scales, galaxies do not scatter randomly, but gather along luminous threads woven together into a structure resembling delicate lace. Between these filaments lie enormous quiet voids, while the threads themselves glow softly with countless galaxies. Seen from far enough away, the universe resembles something almost woven, almost alive in its patterning. Dark matter provides the scaffolding for galaxy formation. Though invisible and undetected directly, its gentle gravity gathers ordinary matter into place, shaping the great filaments and clusters we observe. Without this quiet, unseen framework, Galaxies might never have gathered close enough to form. It moves like an unseen hand, softly holding the visible universe in its shape. Stars form from collapsing clouds of gas and dust. Within vast, cool nebulae, gravity slowly draws scattered matter inward, gathering it into denser and denser knots. Over many thousands of years, these knots warm, brighten, and begin to glow from within. Eventually, a new star ignites quietly at the center, a small ember kindled from cosmic dust. Stars produce heavier elements through nuclear fusion. Deep within their glowing cores, immense pressure and heat fuse simple hydrogen into helium, and over time, into heavier elements still. Every star acts as a slow, patient forge, quietly building the raw materials that will one day form planets, oceans, and living things. The calcium resting quietly in your bones was once assembled inside a star's gentle furnace. Supernovae scatter newly formed elements across space. When a massive star reaches the end of its long life, it releases its treasures in one great, luminous exhale. Elements forged deep within its core are carried outward on shells of light, drifting gently through the surrounding dark. These scattered gifts settle slowly into new clouds, waiting patiently to become something else. In this quiet way, endings become the seed of future beginnings. Black holes form when massive stars collapse under gravity. When a giant star can no longer support its own weight, its core folds gently inward, sinking beyond any light's return. What remains is a place of profound stillness, where gravity holds everything close and silent. Nothing violent lingers there, only a deep, settled quiet. It is less a wound in space than a place where the universe simply grows very, very still. Galaxies grow by merging with smaller neighboring galaxies. Over billions of slow years, galaxies drift toward one another, drawn by gravity's patient pull. When they meet, their stars rarely collide. Instead, they pass through each other like two mists mingling in the night. Gradually, their shapes blend, spiral arms softening into something new and larger. Even galaxies, in their own vast way, seem to grow through gentle union. Let your body settle a little deeper now, wherever you are resting. There is nothing to figure out, nothing to hold on to. Let your breath grow slow and unhurried, like a tide easing back from the shore. Let your thoughts loosen, drifting apart like soft clouds dissolving into open sky. You need only rest, and let the night hold you gently, exactly as you are. The sun will exhaust its hydrogen fuel in about 5 billion years. For now, it burns steadily, warming our small world with quiet reliability. But like all stars, its hydrogen supply will one day thin and fade. When that distant time comes, it will swell gently into a red giant, its light growing soft and vast. This is not an ending to fear, only a slow transformation, still unimaginably far away. Cosmic microwave background radiation is the afterglow of the Big Bang. Everywhere we look in the sky, a faint, ancient light lingers, a soft residue from the universe's earliest moment. It has cooled and stretched over billions of years, now reaching us as the gentlest microwave hum. This quiet glow is, in a sense, the oldest light there is, still softly present all around us. The observable universe contains roughly 2 trillion galaxies. Each one holds its own quiet multitude of stars, its own soft constellation of planets and possibilities. Scattered across unimaginable distances, they drift like scattered seeds of light through the dark. It is humbling to consider so many galaxies, each glowing softly, each unaware of the others, all part of one vast, silent gathering. Entropy in the universe has been steadily increasing since the Big Bang. Slowly, gently, the cosmos drifts from order toward a softer, more even spread of energy. This unfolding is not sudden or dramatic. but a long, unhurried settling, like warmth spreading evenly through a cooling room. Everything, from stars to snowflakes, moves within this same slow tide, quietly tending toward balance. The second law of thermodynamics governs energy flow throughout the cosmos. It gently reminds us that energy always moves from concentrated to dispersed, from hot to cool, from ordered to relaxed. Stars slowly release their light, warmth drifts outward, and structures loosen over time. This quiet law shapes everything, from the fading embers of a star to the gentle cooling of a cup of tea. Gravity organizes matter into hierarchical structures across scales, from tiny dust grains drawn into planets, to planets gathered around stars, to stars gathered into galaxies, and galaxies gathered into clusters. The same soft pull repeats at every scale. It is a quiet architecture, built without a plan, yet shaping order from chaos again and again. The universe seems to nest itself gently, layer within layer, within layer. Baryon acoustic oscillations imprint a characteristic scale on the cosmic web structure. Long ago, sound waves rippled through the hot early universe, pressing matter into gentle rings before everything cooled and froze in place. That faint echo still lingers today, a soft rhythm written into how galaxies are spaced across the sky. Astronomers call it a fossil sound, a whisper from the universe's first moments, still shaping the quiet architecture of the cosmos. Stellar nucleosynthesis created the carbon that makes up living organisms. Deep inside ancient stars, under tremendous heat and pressure, simple elements fused together into heavier ones, carbon among them. When those stars later released their contents into space, this carbon drifted quietly through the dark, eventually becoming part of new worlds. Every gentle breath we take, every soft heartbeat, carries atoms once forged in the heart of a star long gone. Cosmic rays continuously bombard planets from distant sources. These are tiny, fast-moving particles, born in the explosions of stars and the depths of distant galaxies, drifting for eons before quietly reaching us. Most are gentled by a planet's atmosphere, arriving as nothing more than a faint shower of harmless energy. Even now, as you rest, invisible traces of ancient stellar events are softly passing through the sky above you. The universe is approximately 93 billion light-years in diameter as observed. This vastness is difficult to hold in the mind, yet it need not feel overwhelming. It simply means that light itself, patient and unhurried, has been traveling toward us since the universe was young, carrying gentle glimmers from distances beyond imagining. We rest tonight inside something so large that its edges dissolve softly into wonder rather than fear. Let yourself settle a little deeper now into the softness beneath you. There is nothing to hold on to, nothing to solve, nothing to remember. Let your breath grow slow and even, like a tide easing toward shore. With each exhale, let your thoughts loosen and drift, dissolving gently into the quiet dark, needing nowhere else to be. Self-organization can produce complex order without central control. No single guiding hand arranges a flock of birds turning together in the evening sky, or the branching patterns of frost across a window. Instead, countless small parts follow simple rules, and from their quiet interactions, larger patterns gently emerge. The universe seems to know how to arrange itself, softly from the inside out. Dissipative structures form when energy flows through open systems. A candle flame holds its shape not because it is solid, but because heat and gases move steadily through it, sustaining a soft, glowing form amid constant change. Whirlpools, weather patterns, and living cells share this same quiet trick, holding their shape by letting energy pass gently through them rather than by standing still. Feedback loops regulate stability in complex physical systems. When a small change occurs, some quiet signal often travels back through the system, nudging things gently toward balance again. A thermostat easing a room's warmth, a planet's climate softening after a disturbance, a star's glow steadying itself through inner pressure, all echo this same soft principle of return and correction. Emergence describes new properties arising from simpler interacting parts. A single water molecule cannot be wet, yet gather enough of them together and wetness quietly appears. A single neuron cannot think, yet billions together give rise to thought itself. Across the universe, from atoms to galaxies, wholes often hold qualities their smaller parts never possessed alone, gently arising from togetherness. Chaos theory shows small changes can produce large-scale effects. A faint shift in air, barely felt, can nudge weather patterns days later into entirely different paths. This sensitivity does not mean the universe is careless, only that it is deeply interconnected, where the smallest movement can softly ripple outward into something far larger. Even now, unseen and unhurried, such gentle ripples are quietly shaping the world. Complex networks display similar structural patterns across different scales. The branching of a river delta echoes the branching of blood vessels beneath skin and the branching of lightning across a summer sky. Whether the network carries water, blood, or electricity, the shape that emerges often looks remarkably alike. It is as though nature keeps returning to a favorite design, drawing it again and again at every size imaginable. Turbulence in fluids exhibits self-similar patterns at multiple scales. A swirl of cream in warm tea contains smaller swirls within it, and those smaller swirls hold even tinier ones, nested gently like whispers within whispers. This same layered swirling appears in ocean currents, in drifting clouds, and in the vast churning atmospheres of distant planets. Scale seems to matter less than the underlying rhythm of motion itself. Snowflakes form intricate patterns through simple physical rules. As water vapor freezes, it follows quiet rules of symmetry, temperature, and humidity, building delicate six-sided lace one crystal at a time. No two snowflakes ever form in quite the same way, yet all obey the same soft physical grammar. From such simple beginnings, endless variations of beauty drift silently down through winter air. Convection cells and fluids resemble patterns seen in galaxy clusters. Warm fluid rises, cools, and sinks again, forming honeycomb shapes on the surface of simmering soup or the churning skin of the sun. Astonishingly, similar cellular patterns appear on the largest scales imaginable in how galaxy clusters organize themselves across the cosmic web. The same gentle rhythm of rising and sinking seems to echo from a kitchen pot to the heavens. Neural networks in brains share structural similarities with cosmic filaments. Under a microscope, branching neurons stretch toward one another like slender threads of light, forming vast webs of connection. Zoom outward across billions of light years, and galaxies arrange themselves along filaments with a strikingly similar branching grace. No one fully understands why such distant scales should echo one another so closely, but the resemblance remains a quiet source of wonder. Let your shoulders soften now, sinking gently into whatever is holding you. Let your breath slow, each inhale a little quieter than the last. There is nothing to solve here, nothing to hold on to. Simply let your thoughts loosen, drifting like slow clouds as your body grows heavier and calmer with every passing moment. Self-organized criticality explains sudden large-scale system changes. Grains of sand, dropped one by one onto a pile, will eventually cause a small slide, though no single grain seems responsible for it. Systems like forests, earthquakes, and even snow slopes often build slowly toward such delicate tipping points. It is a soft reminder that vast changes can grow quietly from countless small, unremarkable moments. Fractals describe repeating patterns found throughout nature. A fern's smallest leaf mirrors the shape of the whole frond, and a coastline's tiniest inlet echoes the curve of the entire shore. These patterns repeat at every scale you look, each part quietly reflecting the whole. It is a gentle geometry, one that nature seems to favor again and again across mountains, clouds, and living things. Information theory quantifies complexity in physical and biological systems. Scientists have found ways to measure how much order, or how much surprise, exists within a system, whether it is a strand of genetic code or the shifting patterns of weather. This shared language lets researchers compare a living cell to a snowstorm, using the same gentle mathematics. Complexity, it turns out, can be measured with a kind of quiet, universal ruler. Thermodynamic gradients drive the formation of complex structures. Wherever warmth flows toward cold, or energy moves from one place to another, nature often uses that flow to build intricate order. Rivers carve valleys this way, storms organize themselves this way, and living cells sustain their structure through similar unseen currents. Complexity, again and again, seems to grow gently from the simple act of energy finding its way somewhere else. Non-equilibrium systems can spontaneously generate ordered patterns. When energy keeps flowing through a system, rather than settling into stillness, delicate structures often rise from the movement itself. A pan of heated oil forms, tidy hexagonal cells, and a chemical solution can pulse with slow, rhythmic waves of color. Nothing designs these patterns from above. They simply emerge, quietly, from matter finding its most graceful way to carry energy through. The cosmic web's node and filament pattern has been compared to slime mold foraging networks. In laboratories, a humble yellow slime mold will stretch its body into branching threads that link scattered food sources with striking efficiency. Researchers noticed those same slender branching shapes echoed in maps of galaxies scattered across the universe. It is a soft coincidence of geometry, two very different scales of existence quietly arriving at a similar way of connecting distant points. Galaxy clusters behave like nodes in a vast interconnected network. Great gatherings of galaxies sit at the crossing points of long cosmic filaments, joined together by threads of gas and dark matter stretching across unimaginable distances. Matter flows gently along these threads, much like travelers moving along quiet roads between distant cities. The universe, seen this way, resembles a softly glowing map of connections rather than a scattering of separate lights. Star formation and death mirror cycles of birth and decay in organisms. Deep within quiet clouds of gas, young stars gather and begin to shine, much as a seed slowly awakens into a seedling. Later, after long lives of steady light, those same stars fade, swell, or scatter their outer layers back into space. The pattern feels strangely familiar, this slow turning from beginning to ending, echoing the rhythms we know from living things on Earth. Black holes have been compared to digestive systems consuming matter. Gas, dust, and even wandering stars can spiral slowly inward toward a black hole's edge, drawn by gravity's patient pull. Some of this material disappears from view, while other portions are flung back outward in glowing jets of light. Scientists sometimes liken this quiet process to how a body draws in nourishment and releases what it does not keep. Galactic recycling of gas resembles metabolic nutrient cycling. Within a galaxy, gas is drawn into forming stars, then released again through gentle stellar winds and the soft aftermath of stellar deaths. This material drifts, cools, and eventually gathers once more into new stars, turning endlessly through the galaxy's quiet body. It is a slow, patient circulation, not unlike the way nutrients move gently through a living system, again and again. Let this be a moment to simply rest. Let your shoulders soften into whatever is holding you. Let your breath slow, without needing to try. There is nowhere to be right now, nothing to solve, nothing to hold on to, just this soft quiet, this gentle weight of stillness, carrying you a little further towards sleep. Supernova remnants reseed space with material for new stars, akin to reproduction. When a massive star reaches the end of its life, it releases its elements outward in a great luminous cloud that slowly cools and spreads. Within that scattered material lie the seeds of future stars, and perhaps future worlds. In a quiet sense, one star's ending becomes the gentle beginning of others, much as living things pass life onward through what they leave behind. Some scientists compare galaxy formation to embryonic development. In its earliest ages, the universe held only faint irregularities in an almost uniform mist of matter. Slowly, gravity coaxed these subtle differences into growing clumps, which folded and gathered into the shapes we now call galaxies. Researchers sometimes describe this steady unfolding with the same gentle language used for a growing embryo, structure emerging patiently from a simpler beginning. The cosmic web has been described as an emergent circulatory system. Long filaments of gas and dark matter stretch between galaxy clusters, quietly carrying matter from one region to another across vast stretches of space. Some researchers find this flow reminiscent of a living circulatory system, gently moving what is needed to where it is needed. It remains a poetic comparison, offered softly, rather than a literal claim about life itself. Researchers have modeled galaxy clustering using techniques borrowed from neuroscience. The same mathematical tools once built to study how neurons connect within the brain have found a second life among the stars. Scientists studying the arrangement of galaxies sometimes apply these methods to trace patterns of connection across unimaginable distances. It is a quiet borrowing between fields, one shaped by curiosity rather than certainty, each science lending the other a fresh way of seeing structure. Some researchers compare the cosmic web's connectivity to social network topologies. In both, small clusters gather into larger groups, and a handful of especially connected hubs link vast reaches together. A cluster of galaxies, in this soft comparison, might resemble a well-connected community, gathering and exchanging across long distances. It is simply a way of noticing how connection itself seems to follow familiar shapes, no matter the scale it appears upon. Cosmic filaments transport matter much as veins carry nutrients through a body. Along these vast threads of gas and dark matter, material drifts slowly from emptier regions toward denser clusters, feeding the galaxies that gather there. The motion is unhurried, spanning millions of years, yet steady in its quiet direction. It offers a soft image, something being carried, something being nourished, on a scale too vast to fully picture. Dark matter halos have been likened to skeletal frameworks supporting galaxies. Though invisible to any telescope, this unseen matter is thought to form the underlying shape that ordinary matter settles into, much as bones give quiet structure to a body. Galaxies are believed to rest within these vast unseen scaffolds, held together by a gravity we cannot directly see. It is a gentle image of hidden support, holding up what we do see from somewhere just out of sight. Stellar nurseries have been compared to biological wombs. Within these vast clouds of gas and dust, gravity slowly gathers material inward until, at their softly glowing centers, new stars begin to take shape. The comparison feels natural, a sheltered space where something new quietly forms before its eventual arrival into the wider universe. These clouds glow gently in shades of rose and amber, cradling their small forming lights. Some cosmologists describe galaxies as cells within a larger cosmic organism. In this soft way of thinking, each galaxy might be seen as a small living unit, gathering matter, producing energy, and connecting outward to its neighbors. Together, countless such units might form something resembling a single vast body, spread across unimaginable distance. It remains a gentle metaphor, offered to help the mind hold something too large to otherwise grasp. The rate of cosmic structure growth parallels certain biological growth curves. Just as a young organism grows quickly before gradually slowing toward a steady maturity, the universe's structures once formed rapidly in its earlier ages and now continue to develop at a gentler, more measured pace. Scientists studying this pattern of expansion sometimes notice the same soft curve that describes living growth. It is a quiet echo found in the shape of change itself. Let yourself settle a little deeper now. There is nothing to hold on to, nothing to think through. Let your breath grow slower, longer, softer, like a tide easing back from the shore. Feel the weight of your body sinking gently into rest. Nothing is required of you now. Only this slow, unhurried drifting, carrying you further into stillness, further into sleep. Recurring cosmic cycles echo the birth, death, and rebirth pattern seen throughout life. Stars are born from clouds of gas, live out their long stretches of light, and eventually release their material back into space, where it may gather again into something new. This pattern repeats endlessly across the universe, in rhythms far slower than any single lifetime. It is a soft echo of renewal, written quietly into the fabric of the cosmos. Information exchange in gravitational systems carries a soft parallel to biological signaling. Just as living cells send subtle chemical signals to coordinate their actions, massive bodies in space exchange gravitational influence, shifting the motion of distant matter in response. Neither truly communicates in the way living things do, yet both show a kind of responsiveness, a soft attentiveness between separated parts. It remains a quiet resemblance, offered gently, rather than a claim of true awareness. Some physicists model the universe's evolution using tools borrowed from systems biology. They study cosmic structures, the way researchers study living populations, watching how matter organizes, spreads, and settles into balance over vast stretches of time. These mathematical tools were built to describe growth and regulation in living things. Yet they seem to fit the cosmos with surprising ease. It remains a borrowed language, offered gently to help describe patterns too vast for simple words. The universe's homeostasis, like stability, echoes the way living things regulate themselves. Just as a body maintains a steady inner temperature despite the changing world outside, certain cosmic balances, like the gentle equilibrium between expansion and gravity, seem to hold steady across immense stretches of time. This steadiness is not choice or awareness, only physics finding its balance. Still, it softly resembles the poised stillness we recognize inside a living body at rest. Comparisons between metabolism and stellar energy production remain purely descriptive, a way of speaking rather than a claim of true similarity. Stars convert matter into light and warmth much as living bodies convert food into energy, and the resemblance can feel striking. Yet scientists are careful to note that a star does not eat, digest, or sustain itself the way an organism does. The comparison simply helps us hold something vast within a familiar, comforting shape. The Gaia hypothesis proposes that Earth functions as a single, self-regulating system. In this gentle idea, the planet's air, oceans, rocks, and living things are imagined as working together, quietly maintaining conditions suitable for life to continue. It does not suggest the Earth is conscious, only that its many parts interact in ways that create a kind of natural balance. It is a soft, unifying way of picturing our world as something whole. Gaia theory suggests that life and environment co-evolve together, each shaping the other toward greater stability. As living things breathe, grow, and decompose, they slowly alter the air and soil around them, and those changes in turn shape how life continues to unfold. Over unimaginable stretches of time, this quiet exchange has helped keep conditions on Earth remarkably steady. It is a slow, patient conversation between life and the world that holds it. Some thinkers extend Gaia-like reasoning, speculatively toward planetary-scale ecosystems beyond our own. They wonder whether other worlds, if rich enough in complexity, might also settle into their own quiet balances between matter and living processes. This remains a gentle extension of imagination rather than a proven idea, offered softly as a possibility. It invites us to consider that balance itself might be something worlds can find, wherever life is given room to grow. Lynn Margulis, a scientist central to Gaia theory, argued carefully that it describes planetary self-regulation, not the planet itself as a living being. She emphasized that Earth's balance arises from the collective activity of countless organisms, not from any single living entity called Gaia. This distinction mattered deeply to her, keeping the idea grounded in biology rather than myth. It is a gentle reminder that wonder and precision can rest together. Analogies between organisms and planets remain metaphorical rather than literal, offered as gentle bridges for understanding rather than exact descriptions. A planet does not breathe, feel, or intend, yet the patterns of balance it shows can resemble the patterns we see in living things. Scientists use these comparisons carefully, aware of where the resemblance ends. It is a soft borrowing of language, meant to illuminate, never to claim more than the evidence allows. Let your thoughts grow quiet now, like a room settling into evening light. There is nowhere you need to be, nothing you need to hold. Let each breath arrive a little slower than the last, releasing gently as it leaves you. Feel your body growing heavier, softer, sinking further into the warmth beneath you. Just drift, unhurried, as your mind grows still and sleep gathers softly around you. Ecosystem-level self-regulation on Earth helped inspire broader, living universe metaphors that reach beyond our single planet. If one world can hold itself in balance through the quiet cooperation of its parts, some wondered whether the same gentle logic might stretch outward across galaxies and cosmic structures. This is not a claim that the universe breathes or feels, only a soft, imaginative leap from one balanced system to the possibility of another, faster one. Some researchers use metabolism as a metaphor to describe the way energy moves through a galaxy. Gas falls inward, stars ignite, light and heavier elements are released, and matter cycles onward into new formations. Spoken this way, a galaxy can sound almost like it is breathing, taking in fuel and releasing warmth. The words are borrowed gently from biology, chosen to help the mind picture something vast in familiar, comforting terms. The term cosmic ecology describes the quiet exchange of matter and energy between galaxies as they drift near one another across unimaginable distances. Gas streams softly from one galaxy into another. Stars are born from borrowed material, and light travels between them like a slow, patient conversation. Astronomers use this ecological language because it captures the sense of interdependence they observe. Nothing here implies consciousness, only a vast, interconnected exchange, echoing patterns we recognize from life on Earth. Astrobiologists gently debate whether patterns resembling life truly point toward biological processes, or whether they simply look similar from a distance. A spiral galaxy may resemble a seashell. A filament may resemble a root system. Yet resemblance alone proves little. This ongoing, careful conversation keeps science honest, inviting curiosity without asserting certainty. It is a soft, patient kind of questioning, the sort that deepens wonder rather than settling it. Pattern similarity alone does not establish that two things function in the same way, and scientists hold this thought carefully. A river delta and a lightning bolt share a branching shape, yet one carries water and the other carries electric charge. In the same gentle way, cosmic structures may resemble living systems without behaving like them. Recognizing this difference lets wonder remain honest, admiring the shape of things without mistaking the shape for the substance. Cosmological natural selection is an idea suggesting that universes might reproduce through black holes, each one seeding the birth of another. In this gentle hypothesis, when a massive star collapses into a black hole, a new region of spacetime might form beyond it, carrying forward slightly altered physical properties. Across unimaginable spans of time, this could resemble a kind of cosmic inheritance. It remains a graceful, speculative idea, offered softly rather than proven. The physicist Lee Smolin gave this idea its name, calling it cosmological natural selection. During the 1990s, he wondered whether the deep patterns of evolution, so familiar from biology, might echo faintly at the scale of universes themselves. His proposal was bold in imagination yet careful in its uncertainty. Offered as a thought experiment to expand how physicists might picture cosmic history, it remains a gentle invitation to wonder, not a settled conclusion. Smolin's hypothesis gently implies that universes able to form more black holes might, in some imagined sense, be more likely to produce offspring universes. Over vast stretches of speculative time, this could favor universes especially good at forming stars, since stars are what eventually collapse into black holes. It is a soft echo of natural selection, borrowed carefully from biology and stretched with humility across the scale of entire cosmoses. Fecund Universes theory frames the unfolding of cosmic history as a distant cousin of biological reproduction, universes giving rise to further universes across incomprehensible timescales. The word fecund, meaning fruitful or richly generative, was chosen deliberately, evoking abundance rather than mechanism. It offers a poetic lens for imagining cosmic origins, gently borrowing the language of birth and lineage to describe something science still cannot fully see or measure. The multiverse hypothesis proposes that many universes might exist beyond our own, each perhaps governed by its own subtly different physical laws. In some, gravity might be stronger or weaker. In others, the very constants shaping atoms might differ. Our universe, with its particular balance, would then be only one gentle variation among countless possibilities. This remains a graceful, unproven idea, offered with humility, reminding us how much still lies beyond the reach of certainty. Let yourself settle a little deeper now, into the stillness gathering around you. There is nothing left to consider, nothing left to hold on to. Let your shoulders soften. Let your hands rest without effort. Let your breathing slow into its own easy rhythm. With each exhale, feel yourself sinking further into comfort, drifting gently, farther and farther from thought, closer and closer to sleep. Eternal inflation gently proposes that the process which birthed our universe may never truly stop, endlessly spawning new universes across a vast, unseen expanse. In this quiet picture, our cosmos would be just one bubble among countless others, each one forming, expanding, and settling into its own laws. It is a soft, sprawling idea, offering a picture of creation as something continuous rather than singular. Cyclic models offer another gentle possibility, suggesting our universe might expand, gradually slow, and one day collapse inward, only to bounce back into a new expansion once again. Some imagine this happening again and again, cycle after cycle, without any true beginning or end. It is a soothing, patient vision, cosmic time folding like a slow, repeating breath. The ekpyrotic model, meaning conflagration in ancient Greek, suggests our universe might have been born from the gentle collision of two vast invisible membranes drifting through higher dimensions. When these membranes touch, the theory imagines a soft release of energy, sparking something like a big bang. It remains speculative, yet it offers a strangely tender image, creation arising from a quiet meeting rather than a single explosive burst. Conformal cyclic cosmology, proposed by physicist Roger Penrose, imagines that once a universe grows old, thin, and nearly empty, it might smoothly transform into the beginning of another. In this gentle mathematical vision, the vast stretched emptiness at the end of one era becomes, in a sense, indistinguishable from the dense beginning of the next. It is a quiet, elegant thought, suggesting that ending and beginning might one day be the same soft threshold. Some theorists gently compare the earliest moments of cosmic inflation to the growth of an embryo, both unfolding through rapid, patterned expansion from something impossibly small. Just as a single cell divides and organizes into greater complexity, the early universe stretched and smoothed itself into the vast structure we see today. It is only a comparison, offered softly, yet it lets the mind hold two kinds of beginning side by side. Digital physics offers a quieter, more abstract idea, suggesting that the universe might function something like a vast, unfolding computation. In this view, particles and forces would be patterns of information processed according to simple underlying rules, much like a program running quietly in the background. Reality, in this gentle framework, would be less like solid matter and more like a continuously unfolding calculation, vast beyond imagining. Some theorists propose that spacetime itself might not be perfectly smooth, but instead built from tiny, discrete units at the smallest imaginable scale, known as the Planck scale. In this gentle picture, space would resemble a fine, unseen grid, far too small for us to ever notice in daily life. It is a quiet, careful idea, suggesting that even the fabric of the universe might have its own delicate texture. The it-from-bit hypothesis, put forward by physicist John Wheeler, gently suggests that reality itself might emerge from information, rather than information simply describing reality. In this view, every particle, every field, every quiet law of physics could ultimately trace back to answers to simple yes or no questions. It is a delicate, abstract thought, hinting that beneath matter and energy, something like pure information might be quietly holding everything together. Integrated information theory offers scientists a way to measure consciousness, suggesting that awareness arises when a system integrates information in a way that cannot be broken into separate, independent parts. The more richly connected and unified this information becomes, the theory suggests the more that system might experience something like awareness. It remains a careful mathematical framework, developed to understand minds, though its reach has quietly stretched further. A few researchers have speculatively wondered whether integrated information theory might, in principle, be applied to vast cosmic structures, asking whether extremely interconnected systems, like the cosmic web, could possess some faint trace of integration. This remains a gentle thought experiment, far from any scientific consensus. Offered with careful humility, it invites us to wonder, softly, without needing an answer, just how far the language of mind might reach. Let your breathing settle now, slow and unhurried, like a tide gently receding. Feel your shoulders loosen, your jaw soften, your hands grow heavy and still. There is nothing to solve tonight, nothing to hold on to. Just let each thought drift past like a cloud, in no rush to become anything at all, as your body sinks a little deeper into rest. Panpsychism proposes that consciousness might be a fundamental property of matter itself. In this quiet view, even the smallest particles could carry some faint trace of inner experience, long before brains ever existed. It does not claim atoms think or feel as we do, only that something like experience might run through everything, however faintly. It is an old idea, dressed in new language, inviting us to wonder softly about what matter truly is. Cosmopsychism suggests the universe itself could be a single conscious entity, rather than consciousness arising piece by piece within it. In this gentle framing, our own minds might be small expressions of something vast and unified, the way a wave belongs to the ocean. It remains a speculative, philosophical idea, offered without certainty, yet it carries a tender kind of comfort, imagining the cosmos as one quiet, feeling whole. Idealist philosophies propose that the universe is fundamental rather than material, suggesting that mind, not matter, may be the deeper foundation of reality. In this view, physical things would be expressions of something more like thought or experience, rather than experience arising from physical things. It is a gentle inversion of the usual picture, quietly asking which came first, the substance or the awareness of it. Some physicists speculate that space-time itself could encode proto-conscious information, a faint precursor to experience woven into the very structure of existence. This remains a careful, exploratory idea, far from proven, offered gently as a bridge between physics and philosophy. It imagines that the fabric holding galaxies and moments together might carry more than geometry alone, perhaps something faintly resembling the seed of awareness. The simulation hypothesis suggests that our universe could be a computed reality, generated by processes we cannot directly perceive. In this quiet thought experiment, stars, oceans, and even our own thoughts might arise from underlying computation, much like a vivid dream arises from a resting mind. It is offered with humility, as a philosophical curiosity rather than a claim, gently inviting us to wonder what reality is truly made of. Philosopher Nick Bostrom's simulation argument raises careful questions about the nature of reality, suggesting that advanced civilizations might one day create detailed simulated worlds. If such simulations were possible and common, he gently reasoned, simulated experiences could vastly outnumber original ones. It remains a thought experiment in probability and philosophy, not a scientific finding, offered softly as an invitation to sit with uncertainty rather than resolve it. Quantum entanglement has inspired speculative ideas about universal interconnectedness, since two entangled particles can share a strange, instantaneous correlation, no matter how far apart they drift. Scientists understand this deeply within quantum physics itself, without needing anything mystical to explain it. Still, some have gently wondered aloud whether such deep connection might hint at a subtler kind of unity threading quietly through the wider universe. Some interpretations of quantum mechanics imply that the act of observation might shape the outcome of physical events at the smallest scales. Before being measured, particles seem to exist in a soft haze of possibilities, only settling into a definite state once observed. Physicists still hold gentle disagreements about what this truly means, yet it quietly suggests that watching and being watched may be more intertwined than once imagined. The participatory universe idea suggests that observation itself may play a quiet role in physical existence, as though reality unfolds partly through the presence of observers within it. This gentle notion does not claim we invent the cosmos, only that our looking may be woven somehow into how it takes shape. It remains a tender, unresolved thought, offered as wonder rather than certainty, as the universe continues patiently to be seen. Physicist John Wheeler proposed the universe as a self-observing system, imagining reality as a great loop where the cosmos gives rise to observers, and observers in turn help give the cosmos its concrete form. He pictured a universe reaching back through time, gently completing itself through the presence of eyes and minds within it. It remains a graceful, speculative vision, offered with wonder rather than proof, of existence quietly watching itself into being. Let your shoulders soften now, and let your breathing slow a little further. There is nothing to solve here, nothing to hold on to, just the slow rise and fall of breath, the quiet weight of your body sinking into rest. Let every thought loosen and drift, like light dissolving gently into the dark. You are exactly where you need to be, resting, unhurried, safe. Some cosmologists speculate the universe tunes itself through feedback processes, imagining unseen loops where conditions somehow adjust across vast stretches of time. This remains a gentle hypothesis, not an established mechanism, offered as a way of wondering how such delicate balance might arise. Still, it invites a soft curiosity about whether stability could emerge not by chance alone, but through some quiet, self-correcting rhythm. The anthropic principle notes that physical constants appear finely suited for life's emergence, as though the universe's basic numbers were tuned with quiet precision. Change gravity or the strength of nuclear forces even slightly, and stars, atoms, or chemistry itself might never have unfolded. Scientists still debate what this delicate suitability truly means, holding the observation gently, as a wonder rather than a certainty. Some argue that fine-tuning implies the universe's structure resembles biological adaptation, as though its constants had settled, over vast stretches of time, into a shape hospitable to complexity. This remains an interpretation, not a proven process, offered softly as a bridge between physics and biology's familiar language. It gently invites us to wonder whether adaptation, so central to life, might echo faintly in the shaping of the cosmos itself. Cosmological selection ideas remain unproven and highly speculative, existing at the edge of philosophy and physics rather than within settled science. Researchers hold them loosely, as gentle possibilities worth exploring rather than conclusions to defend. It is perhaps one of the softest kinds of wonder, sitting comfortably with not knowing, letting the question rest unresolved beneath a wide and patient sky. Complexity theorists speculate the universe might tend toward greater self-organization over time, as matter slowly gathers into stars, galaxies, and vast filamented webs. This drift toward pattern and structure happens without any central plan, guided only by physics playing out across immense stretches of time. Some find in this a quiet echo of how living systems, too, seem to build order from simplicity. Some physicists propose the universe's growth resembles a developing organism, unfolding through stages, the way an embryo grows from a single cell into something vast and structured. Early density ripples slowly bloomed into galaxies, clusters, and the great cosmic web we observe today. It is offered as a tender metaphor for cosmic evolution, a way of feeling the shape of billions of years within a single, gentle image. Speculative models suggest black hole networks might function like neurons, exchanging influence across cosmic distances through gravity and the slow bending of surrounding space. In this gentle picture, black holes become nodes in some vast unseen signaling web, their connections resembling the branching pathways within a mind. It remains imaginative rather than proven, a soft way of picturing the universe's deep architecture. Some cosmologists speculate that dark matter halos could form an interconnected communication network across galaxies, threading unseen structure quietly between them. In this gentle idea, invisible mass becomes a kind of scaffolding for subtle influence, linking distant galaxies the way roots link trees within a hidden forest floor. It remains a speculative, poetic possibility, resting softly at the edge of current understanding. Vast computer simulations, tracking billions of particles across cosmic time, show structure forming in branching patterns that resemble river networks spreading across a delta. Matter flows along invisible channels, gathering into filaments that split and rejoin, echoing the way water finds its path across land. Scientists find this resemblance striking, though it arises simply from gravity's patient pull. The universe, it seems, favors certain shapes wherever flow and gathering occur. Complexity science suggests that lifelike behavior may not require anything biological at all. Certain rules of interaction, feedback, and flow can produce patterns that look organized, adaptive, even purposeful, in systems made only of sand, light, or numbers. This tells us that the appearance of aliveness may be a property of certain kinds of order, wherever it arises. The universe, full of flowing energy and shifting matter, offers countless places where such order could quietly emerge. For now, let yourself rest inside this soft unfolding. There is nothing to hold on to, nothing to solve. Let your shoulders sink a little deeper. Let your breath grow long and unhurried. Every thought that passes may simply drift away, like light fading gently at the edge of the sky. You are exactly where you need to be, resting, listening, letting go. The philosopher Baruch Spinoza, writing quietly in the 1600s, described nature and the universe as one single substance expressing itself in countless forms. To Spinoza, there was no separation between the divine and the physical world. All things were simply expressions of one vast, unified reality. Stars, oceans, thoughts, and stones were not separate substances, but different faces of the same underlying whole. It was a philosophy that dissolved boundaries, inviting a feeling of belonging to something seamless and entire. Long before modern cosmology, many ancient philosophies described the cosmos as a living organism, breathing and growing much like the creatures within it. Thinkers across different cultures imagined the heavens as something animated, sensing, and whole, rather than cold or mechanical. This view offered comfort, a sense that the universe was not indifferent, but alive with its own quiet vitality. It is a gentle thread that runs through much of early human thought. The Stoics, philosophers of ancient Greece and Rome, believed the universe was infused with a rational living soul, which they called the Logos. To them, this soul wove through all things, guiding events with quiet purpose and order. Even the stars and seasons were thought to move, according to this deep, reasoning presence. It was a worldview that saw harmony not as accident, but as the gentle expression of a living mind. In his dialogue, Timaeus, Plato described the cosmos as a single living creature, endowed with a soul and intelligence placed there by its maker. He imagined the stars and planets as parts of this vast being, moving in accordance with reason and harmony. This creature, Plato wrote, was whole and complete, lacking nothing, containing all things within itself. It remains one of philosophy's oldest visions of a universe that thinks and lives. Across the world, indigenous cosmologies frequently depict the universe as inherently alive, filled with spirit, breath, and relationship. Many traditions see mountains, rivers, and stars as kin, part of a living web that includes human beings without placing them above it. This understanding is not separate from daily life, but woven through ceremony, story, and care. It reflects a deep, enduring sense that existence itself is animated and related. Hindu cosmology describes vast cycles of creation and destruction, unfolding across immense stretches of cosmic time. In this view, universes are born, flourish, and dissolve, only to be born again, echoing endlessly like breath. These cycles are often symbolized by the gentle motion of a divine dance, neither beginning nor ending, but forever turning. It offers a way of seeing existence as rhythm, rather than a single line toward an end. Many mythologies around the world personify the universe as a nurturing cosmic being, often imagined as a mother who births and sustains all things. Stars become her children, the sky her body, and the unfolding of time her gentle care. This image appears across countless cultures, distant from one another yet strangely alike in tenderness. It suggests a shared human instinct to feel held by something vast, alive, and kind. Process philosophy suggests that reality is not made of fixed things, but of interconnected experiential events, each one arising, blooming briefly, and passing into the next. In this view, a star, a thought, and a heartbeat are all momentary happenings, threads in a single unfolding tapestry. Nothing simply sits still. Everything is becoming, endlessly weaving itself into what comes after. The philosopher Alfred North Whitehead proposed that all matter carries some faint degree of experience, however small. He imagined even the simplest particle as having a trace of inner feeling, a whisper of perspective on its own existence. This idea, called process philosophy, does not claim atoms think or dream. It simply suggests that experience may run deeper into nature than we once assumed. Some modern physicists find a quiet resonance between panpsychism and the strange behavior of quantum theory. They notice that both frameworks treat reality as something relational, shaped by connection rather than isolated substance. This is not proof of anything, only a gentle overlap in language and imagination. Still, it invites a soft curiosity about how deeply intertwined mind and matter might be. For a little while now, let your thoughts move slower, like a river losing its current as it nears the sea. There is nothing to solve tonight, nothing to hold on to. Let your shoulders soften, let your breath grow long and unhurried. Wherever your mind wanders, let it drift without effort, gently sinking toward rest. Speculative cosmology sometimes borrows gentle metaphors from developmental biology to describe the universe's early growth. Just as an embryo unfolds through stages of differentiation, some theorists imagine the young cosmos passing through phases of structure and organization. This comparison is poetic rather than literal, a way of picturing change through a familiar lens. It offers a tender image of a universe still finding its shape. Some theorists explore whether tiny fluctuations within the quantum vacuum could, under certain conditions, give rise to entirely new physical laws within nascent universes. In this speculative picture, each infant cosmos might inherit its own quiet variation of nature's rules. It remains a delicate hypothesis, resting at the edge of current understanding. Yet it invites a soft wonder about how many different ways existence might unfold. Speculative meta-law theories suggest that even the laws of physics themselves might not be fixed forever, but could shift and evolve over vast stretches of time. In this view, the rules we observe today are not eternal instructions, but patterns that emerged and could change under different cosmic conditions. It is a quiet, expansive idea. It suggests that even nature's deepest structure may have a kind of history. The cosmologist Lee Smolin proposed that physical laws themselves might change from one universe to another, rather than remaining the same everywhere. In his view, each new universe could inherit slightly altered constants, shaped by the conditions of its birth. This idea remains speculative, resting gently at the edge of testable science. Still, it offers a serene image of a cosmos with many quiet variations. Smolin further suggested that universes producing more black holes might be favored in this vast unfolding process. In his hypothesis, each collapsing star could seed a new universe, and those with laws suited to abundant black hole formation might simply produce more offspring. It is not unlike how traits that support survival become common in living populations. The comparison is gentle and speculative, not a claim of biology, but of pattern. Some speculative models describe the slow increase of entropy across the universe as a kind of cosmic aging. In this quiet metaphor, the universe grows older not through wrinkles or years, but through a gradual settling toward stillness and disorder, just as living things move through stages of change. Some imagine the cosmos following its own long, unhurried arc. It is a soft way of picturing time's gentle passage on the grandest scale. Heat death, the far distant state of maximum entropy, has sometimes been spoken of gently as the universe's own passing. In this quiet metaphor, the cosmos does not end suddenly, but fades, its stars long dark, its energy spread so thin that nothing more can happen. Some find this image sorrowful. Others find in it a strange, soft peace, the same peace that comes at the close of any long and gentle life. Some cyclic cosmologies imagine heat death not as an ending, but as a quiet threshold before renewal. In these gentle models, the stillness of maximum entropy becomes the very condition from which a new universe might begin. Endings and beginnings blur softly together, like the last light of evening dissolving into the first hush of night. It is a comforting shape for cosmic time, a circle rather than a line. A few physicists have wondered, gently and speculatively, whether a future universe might carry forward faint traces of the one before it. In such musings, perhaps certain patterns, certain tendencies, could pass quietly from one cosmic age into the next, much as inherited traits pass between generations of living things. It remains a delicate hypothesis, resting far from proof. Still, it offers a soothing image of continuity, stretching gently beyond any single universe's span. Dark energy, the unseen force behind the universe's gentle acceleration, has occasionally been cast in speculative writing as something like an animating current. In these imaginative frames, it becomes almost a quiet life force, pressing space outward with patient, unseen persistence. Scientists are careful to note this is metaphor, not measurement. Still, the image lingers softly, of a hidden breath moving quietly beneath everything we see. For a moment, let your thoughts loosen and drift, with nothing left to hold on to. Feel your breath slow, unhurried, moving in and settling out, like a tide easing along a quiet shore. Let your shoulders soften into the surface beneath you. Let your eyelids grow heavy and still. There is nowhere to be, nothing to solve. Only this soft, settling quiet, carrying you gently toward sleep. A few thinkers have proposed, softly and speculatively, that consciousness itself might simply be what happens when complexity grows deep enough. In this view, awareness is not planted from outside, but arises naturally, the way intricate patterns emerge from countless simple interactions. The universe's vast complexity, in this gentle framing, could be fertile ground for something like mind to quietly take shape. It remains an open question, held with curiosity rather than certainty. Some have wondered whether a truly living universe would need to reproduce itself on the grandest possible scale. In this careful view, life is defined partly by its ability to copy itself forward, and a cosmos would need some equivalent, universes birthing universes, patterns passing onward. It is a demanding standard, one the evidence does not yet meet. Still, it offers a thoughtful boundary for where the metaphor of a living universe might end. Others gently counter that what looks like cosmic self-organization is simply physics unfolding as it always does. In this steadier view, gravity, thermodynamics, and chemistry are fully sufficient to explain the patterns we admire, without needing any biological framing at all. The structures may resemble life, but resemblance is not the same as kinship. This perspective holds its own quiet clarity, content to let physics simply be physics. Across the scientific community, the idea that the universe is alive is understood as a metaphor, a way of speaking, rather than a literal biological claim. Researchers use such language to illuminate patterns, not to suggest the cosmos breathes or feels. This distinction is held gently but firmly. It allows the poetry of comparison to exist comfortably alongside the discipline of careful evidence. Most physicists draw a clear, gentle line between complexity that emerges naturally and life in its true biological sense. A snowflake's intricate branching, a galaxy's spiral arms, a cluster's flowing filaments, all can be beautifully complex without being alive. Life requires specific processes, metabolism, reproduction, response to its surroundings, that the universe as a whole has not been shown to possess. The distinction keeps wonder honest, letting all rest on solid ground. No experiment to this day has detected anything resembling awareness within the cosmos itself. Instruments that measure light, gravity, and radiation find no trace of a mind behind the patterns they capture. Every observation remains consistent with a universe governed by physical law alone. Scientists hold this absence gently, not as disappointment, but as an honest boundary of what careful measurement can currently tell us. Skeptics gently remind us that seeing life in the cosmos may say more about us than about the universe. Humans naturally search for faces in clouds and stories in starlight, a tendency shaped by our own biology. Recognizing patterns of growth or breathing in galaxies might simply reflect this deep human habit. It is a humble caution, inviting us to admire the cosmos without mistaking our own reflection for its truth. The question of a living universe still belongs more to philosophy than to laboratory science. No measurement can currently confirm or deny it, so the conversation unfolds instead through reasoning, metaphor, and careful thought. Philosophers and physicists alike find value in the dialogue, even without resolution. It remains a spacious, open inquiry, one that invites reflection rather than demanding proof. Some scientists gently warn against letting comforting metaphors stand in for actual mechanisms. Saying a galaxy behaves like a cell can illuminate a pattern, but it does not explain the underlying physics. Confusing the two, they caution, risks mistaking poetry for proof. This careful distinction protects the integrity of both language and science, letting each do what it does best. To truly test whether the universe is alive, scientists would first need a clearer definition of life itself. Our current definitions were built entirely from examples found on Earth, a single small sample of what life could be. Expanding that definition to fit something as vast as the cosmos remains an open and delicate challenge. It is less a question awaiting an answer and more a question awaiting better words. For now, let every question rest quietly, unanswered and unhurried. There is nothing left to solve tonight, nothing to hold on to. Let your breathing slow, soft, and even, like a tide settling near the shore. Let your shoulders sink a little further into stillness. Whatever thoughts remain can simply drift, weightless, like dust settling gently through starlight. A few researchers gently propose widening the definition of life to include entire planetary systems. In this view, a planet with oceans, atmosphere, and living things woven together might itself qualify as a single living unit. It is a bold reimagining of an old word, stretching its boundaries outward. The idea remains speculative, offered not as certainty, but as an invitation to think more broadly about what life could mean. Astrobiologists continue searching for universal traits that might define life wherever it appears, on Earth or far beyond it. They study extreme environments, distant moons, and unfamiliar chemistries, hoping to find patterns broader than our own biology. Each discovery refines the search, even without a final answer. It is patient, careful work, quietly expanding what we might one day recognize as alive. Some physicists wonder whether future theories of quantum gravity might reveal deeper layers of self-organization within the universe. If space and time themselves emerge from something more fundamental, perhaps that foundation holds patterns we cannot yet imagine. Such theories remain unfinished, more sketch than structure. Still, they offer a quiet hope that deeper mathematics might one day illuminate why the cosmos organizes itself so gracefully. A number of physicists hope that unifying the language of physics and biology might finally clarify what life truly is. If the same principles that shape galaxies also shape living cells, perhaps a single deeper theory awaits discovery. This hope remains gentle and unproven, a distant lantern rather than a finished bridge. Yet it keeps curiosity alive, inviting patient minds to keep searching for the quiet threads that connect matter and life. The question of whether the universe might be alive gently pushes science to examine the very edges of its own definitions. It asks old words like life, mind, and organism to stretch a little further than before. This is not a weakness in science, but one of its quiet strengths. Each generation redraws its boundaries a little wider, making room for wonder that once seemed too vast to hold. Sitting with the idea of a living universe invites a quiet humility about our own small place within it. We are, each of us, a brief warmth within something unimaginably old and wide. This is not a lonely thought, but a softening one. It asks us to hold our lives gently, aware that we are woven into something far larger than we can fully see or measure. Whether the universe is alive in truth or only alive in metaphor, its endless complexity continues to inspire wonder either way. Galaxies turning, stars igniting, matter arranging itself into patterns of startling grace. All of it moves us, regardless of the words we use to describe it. The feeling of awe does not require a final answer. It simply asks us to keep looking softly and to keep noticing. Across the scientific community, there is quiet agreement that more evidence is needed before any firm conclusions can be drawn. The comparisons between cosmos and organism remain suggestive, not proven. Careful minds continue gathering data, testing models, and questioning their own assumptions. This patience is not hesitation, but care, the kind of care that lets big ideas mature slowly instead of being rushed toward certainty. The living universe hypothesis remains, for now, an open and evolving question rather than a settled truth. It lives in the space between metaphor and possibility, welcomed by some, held at a careful distance by others. Perhaps it will sharpen into something provable one day, or perhaps it will simply remain a beautiful lens for seeing the cosmos. Either way, the question itself has already deepened how many of us look up at the night sky. And perhaps it is fitting that sleep itself follows cycles of rest and renewal, echoing the same quiet rhythms found throughout the living world, and perhaps throughout the cosmos too. Night folds gently into day, just as galaxies turn, stars are born, and stillness follows motion everywhere we look. Wherever you rest tonight, know that you are part of this old, unfolding pattern. Let your breathing slow, let your body soften into the dark, and let sleep carry you gently, the way the universe itself seems to carry everything within it. Good night.